In section 1.3, we looked at the slope-intercept form of a line. In section 1.4, we're going to look at a couple other ways of representing a line with an equation. Each one of these is useful in a different situation and useful for a different purpose. So let's start with the one we already know, the slope-intercept form. This one is best to use if you were given the vertical or the y-intercept. If it's a standard XY Cartesian graph, it would be that y-intercept. It's the one on this part of the axis. And then you're also going to need the slope. So either they'll have to give you the slope in the problem or they'll give you a second point and then you can calculate the slope. This form is really nice if you need to graph a function. And the reason that it's nice is that when you are graphing that function, you would start by plotting that vertical intercept, the value for b. So maybe that value is here. And then you can use the slope and go over and up to get the next point. You can kind of continue that process, and then that gives you a nice, easy way to graph. Okay, so that form is really great if you're given the vertical intercept or if you're looking at doing some graphing. The form that's used most often in mathematics, I know everybody knows this one mostly from high school, but the one that if you continue on in math is used the most often is this point slope form. So this is y minus y1 is equal to m times, in parentheses, x minus x1. And we're going to break down what this is, but this one is great to use if you do not have the y-intercept. So if you have any points, and you could use it if you have the y-intercept as well, but if you have any point at all and the slope, you'll be able to use this form. So that slope is still represented with the letter m, and then that point we represent with x1, y1. Okay, this is also a really good choice to use if you're given 2 points. So if the problem just says find the equation of the line that goes through these 2 points, this is the form you're going to want to use. And the way that you would tackle that is by finding the slope first. And that slope formula, in case you've forgotten, is m is equal to y2 minus y1 over x2 minus x1. So that'll give you the slope, and then you can pick either point to use and put that into the equation. And so that's where that x1 and y1 come from. That's the point you're plugging in. This one's used all the time in calculus for finding the instantaneous rate of change. So we were finding the average rate of change, just the overall difference between 2 points. But if you're looking for the exact change at a single moment in time, that's called the instantaneous rate of change. And that's done using the slope at that point, so with some basic calculus, and then this formula or form here. Right, the last one, we're not going to use this one too terribly much, but this is the other form of a linear function. It's ax plus by plus c equals 0. And we generally get that by just rearranging an equation we already have so that it matches this form. Okay, so this tells me that what I'm looking at is a line. If instead this equation was ax squared plus bx plus cy plus d equals 0, that would be a parabola, which is something we'll look at in chapter 3. If it was ax squared plus bx plus cy squared plus dy plus e equals 0, that would be a circle. And so by rearranging it in this form, if you know what these identifiers are, you could tell exactly what that equation is going to represent. All right, so let's give this a try. The first one here, we're going to find the equation of the line using any of the forms. So the first one says the slope is 7 and the y-intercept is 3. So they gave us the y-intercept here, so that would be a good time to use the slope-intercept form, that y equals mx plus b. And so we know our slope is 7, that's our m. And then our y-intercept is 3. So this equation would be y is equal to 7x plus 3. And then number 2, so they tell us the slope is -2. So that's our m. And then it says the x-intercept is 5. So that would be the horizontal intercept. And to use the slope-intercept, we need the vertical one. So since we do not have that y-intercept, we're going to use this point slope form. So I'm going to take this x-intercept of 5, and I need to turn that into a point. So that point would be x is 5 and y is 0. So there's my x1 and my y1. So that equation is y minus y1 is equal to m times x minus x1. So y minus 0 is equal to, let's see, negative 2 times x minus 5. You are certainly welcome to leave it like this. You don't have to simplify it. You don't need to move things over to the other side. This is perfectly acceptable as an equation.